We're now going to focus on our final lesson in this course, which is to give a summary of the Java Executor framework. We spent a lot of time in this course going through the features in the Java Executor framework. And this will hopefully put all the pieces together for you. Remember, the purpose of the Java Executor framework is to decouple the management and creation of threads from the application logic itself. You can see here we have different kinds of thread pools. We have cached thread pools and fixed size thread pools and work stealing pools. And those can all be varied without changing the interface that's expected by clients that use these implementations. The Java Executors framework itself forms a very large portion of the Java util concurrent package. As you can see here, there's literally dozens of classes and interfaces, and I'm just showing some of the more popular ones. There's even more lurking around here that you would need to be aware of if you wanted to have comprehensive knowledge of all things Executor framework. This framework applies many pattern-oriented software architecture and gang of four patterns. There's a bunch of concurrency patterns that it defines and uses. It defines a bunch of, or applies a bunch of gang of four design patterns. And we've talked about these a little bit as we've gone through the examples, but just be aware that both frameworks, the Executor framework uses these patterns very heavily, which is a sign of a good, well thought out design. Interestingly enough, there are very few Java synchronizers that are used in the Java Executor framework. Really the main thing that's used from a synchronization point of view are condition objects and reentrant locks that are used for the various thread-safe queues. They're bounded queues, things like the array blocking queue or the linked blocking queue or the synchronous queue and so on. And those are the main things that are defined that use synchronizers. But other than that, there's really very little else in the way of synchronizers used in the framework, just because of the way it's designed to give you pools of threads. Instead, as I mentioned, it uses a message passing model, which is based on these thread-safe buffers, which could be, some cases they're bounded buffers, some cases they will grow without bound, but you can control, as we saw in the previous lesson, how those queues are created, and you can control the semantics of them based on the factory methods for the Java Executors utility class. So another thing to keep in mind is that the Java Executors framework provides an imperative model of concurrent object-oriented programming. That's what makes it really so essential for this class's topics, which is concurrent object-oriented programming. But be aware that that's not the only way to do things. And in fact, if you take my sibling class that'll start in the fall, if you're still be at Vanderbilt and have a chance to take that class, we'll be talking about using Java functional programming and parallel functional programming, which is a more declarative model. And things like parallel streams, completable futures, things like Project Reactor or RxJava, those are all frameworks that apply functional programming features and reactive programming features in ways that I think are, arguably more interesting than the more classic concurrent object-oriented programming features we found with the stuff we covered in this class. But having said that, it's very important to understand how these basic core features work, because a lot of Java code today still uses those in production environments. So that's the end of the Java Executor framework. I hope you learned a lot about concurrency in this course and synchronization, of course, and I look forward to hopefully seeing you again next fall.